Leadwerks Engine uses a deferred renderer for lighting. Although this yields many benefits, it does require that we treat alpha blending a little differently than we would with a forward renderer. This lesson will show how to render alpha blending in a second pass, and how this approach can be easily extended to render refraction effects. So I'm going to start with this simple program, and this just creates a sphere mesh, and then I'm going to load this glass.mat material and apply it to the mesh. And then down here in the main loop we just have some camera controls, and then I'm not even going to render lights yet. This is just really simple rendering. And I want to show you what this glass.mat material file looks like. I have it associated with I have the mat extension associated with the material editor, so when I double click on this it will just open in the material editor. And you can see it's just this blended material. I've got the depth mask disabled, which is important, and I'm using the multiply blend. And if we go to the texture tab, we can see that texture unit 0 is this glass.dds texture. And this is just a simple image that I drew up myself. So let's run the program. And you can see here's the material we just saw, and it's being rendered, it's being blended with the background. Now I want to show you what happens when we add lighting to the program. So I've got this example, and here I'm creating a G buffer. And then down here in the main loop, I'm going to render lights like I normally would. And you can see there's something funny going on here with the edges of the sphere. And it's just, the results when you do this are just really unpredictable, because you're rendering the transparent surface before you render the lights. So the renderer doesn't really know what to do with the pixels that are behind the sphere. And this doesn't look too bad, but you'll get very different results on different cards, and it's clearly not working right. So let's see what we can do about that. Now the proper way to render transparency with a deferred renderer is to render the scene first with all the solid objects, and then render lighting on top of that, and then you render your transparent objects in a second pass. And the way we do multi-pass rendering is by creating different worlds. So let's see. I'm going to create a separate world for the transparent object, and I'm going to call this foreground just because it gets rendered after the other world. And of course I have to have a camera for this world for anything to be rendered, so I'm going to create this FG camera, and I'm going to set the clear mode to 0 because I don't want this to clear the results from the previous render. And then I'll create my sphere, and because it's being created after this call to create world, the sphere will be a member of this foreground world. And then down here in my main loop, we're going to render lighting like we would normally until we render we'll render the lights to the back buffer. And then we'll set the world to this foreground world, and we're going to copy the entity matrix from the main camera to the foreground camera, FGCam. Then we call render world, and then we call set world world, and world is this world variable is the first world that we created. So again, we're just rendering everything like we would normally, and then after we're done, we're going to render the transparent object in a second pass. And now we're getting more correct results. We have transparency and lighting combined. So that's how you do simple transparency with lighting. Now I want to show you something with blend modes. I'm just going to open this material file in Notepad, and I'm going to change the alpha value of the color parameter to 0.5, and I'm going to change the blend mode to alpha for alpha blending, and I'll save that. And now I'll rerun this program. Now it looks a little bit odd right now because the alpha blend doesn't really blend well with the background color. And this gets really bad when you have an area that's really dark. Then alpha blended materials will kind of stick out. So multiplicative blend is your best bet for just simple transparency. Now because we're already rendering transparent objects in a second pass, it's not hard to take this idea and extend it a little bit so that we can render refractive surfaces. So to do this, I'm going to load this glass refraction material, and I'm going to set two of the textures to the results from the previous render. So if you'll recall, this G buffer is just a collection of textures that we're rendering to. And we can also read from those textures. So I'm going to call set material texture here, and I'm going to send the color buffer and the depth buffer to this material. The color buffer is from the light buffer, so that will be the results after lights are rendered. And then I'm also going to pass the depth buffer to the material, and this is important for rendering, telling which pixels are actually behind the transparent surface. And I'm also going to get the material shader because we're going to do something else with that down here. And here I just have I have some key controls set up so that when I press the up key, the refraction effect will increase, and when I press the down key, the strength of the refraction effect will decrease. And then I'm just setting this uniform value, refraction strength, every frame. Now the article for this lesson goes into a lot more detail, and I encourage you to take a look at that, but in the video I'll just show you what this does. And you can see it's bending the background behind the transparent surface. And I can use the arrow keys to increase the effect. And we get this nice, really neat looking effect. And I also created this red cube out here so that you can tell that it's not refracting objects that are in front of it. And even though this transparent sphere is being rendered in a second pass, because I copied the depth buffer from the original render to the back buffer before the transparent sphere is rendered, then the renderer still allows objects to occlude this sphere even though it's rendered after the other objects.